Guys, the last thing that we're going to learn in Unit 7 is actually pretty easy. We're going to look at 7.8, something called Euler's formula. So there's this guy out there who's good at geometry or is a mathematician, and his name was Euler. Well, anyway, he came up with a formula that relates the faces, vertices, and the edges of a 3D figure and relates them together in an equation. So basically, if you know the faces and vertices, you can find the edges. If you know the vertices and the edges, you can find the faces. So if you know two of them, you can find the third. And what this equation is the faces, F, plus the vertices, V, minus the edges, E, is always going to equal 2. So if I took the faces, the vertices, added those together, then subtracted the number of edges, it's always going to equal 2. So with any 3D, polyhedron here, we can use this formula and find any one of these to help us out. And then also in your notes, I'm going to have them pop up on the screen. Here are your vocabulary for your notes here. So the first one here, remember, a polyhedron is a three-dimensional figure whose surfaces are polygons. A face is a flat surface of a polyhedron in the shape of a polygon. An edge is a segment that is formed by the intersection of two faces. The vertex is a point where three or more edges intersect. And lastly, it might be a word that you guys haven't learned yet, but a cross-section is the intersection of a solid and a plane is going to be known as a cross-section. Alright, so on this example, we are basically given a polyhedron, and then we need to find the vertices, the edges, and the faces on it, and then I'm going to show you how these are related to each other. So first, let's go and look at the vertices of this triangular prism here, or triangular pyramid, sorry. And so right now, if I look, A, B, C, and D are going to be all of my vertices, so A, B, C, and D are going to be all my vertices, so there's 4 of those, okay? So now let's look at my edges. So right now I have A to B, I have B to C, I have B to D, I have A to D, I have D to C, and then lastly I have A to C. So right now I have 1, 2, 3, 4, 5, 6 edges. And then lastly, we're going to look at my faces. And my faces there's basically going to be triangles of each one of those. So right here on the bottom, I have triangle ADC. On the right side over here, I have triangle ABC. On the back over there, I have triangle ABD. And then lastly, on the other back side right here in purple, I have triangle DBC. Triangle DBC. And so right now on this shape, I have 1, 2, 3, 4 faces. So now let's just go ahead and see if Euler's formula works. So earlier I told you Euler's formula is the faces plus the vertices minus the edges is going to equal 2. Let's go ahead and see if this works out. So right now, my faces, I have 4. Right now on my vertices, I have 4. Then I'm going to subtract my edges, which is 6. And let's see if this is equal to 2. Let's see if this works out. 4 plus 4 is 8. Minus 6 is going to equal 2. So ladies and gentlemen, Euler's formula does work out. So with this being said, now I can use this to help me to find how many edges, vertices, or anything else that's written on it and help me to find it. Example number 2, it wants me to use Euler's formula to find out the number of edges on a polyhedron with faces 6 and vertices 8. So let's go ahead and use this formula. So I know the formula is faces plus vertices minus the edges is always going to equal 2. So what I'm going to do is I'm going to plug everything in, then I'm going to solve for what I need here. So I know the number of faces is 6. I know the number of vertices is 8. And I'm solving for the edges, so I'm going to end up solving for E here, ladies and gentlemen. So now all I need to do is get E by itself, and then figure out what E represents here. So I know 6 plus 8 is going to equal 14, right? So 14 minus E is equal to 2. So I'm going to get the 14 on the other side by subtracting 14 on both sides. So I'm going to get negative e is equal to negative 12, because 2 minus 14 is negative 12. And if I have a negative e, all I have to do is divide by negative 1, which is going to change it to positive. So the number of edges is going to equal 12 on this polyhedron. Boom, done. And that's Euler's formula, ladies and gentlemen. So now you have example 3 and example 4 on the back side of your paper. I want you guys to go and do exactly what we just did on these two examples on your own.